Hi, in this section of the video, we will present to you the steps to create a bridge service on a bridge ONT. So we have a sample setup here. We can see there is a server in the uplink and it's passing traffic on the VLAN 200, and we have here the OLT, and the OLT PON port number 4 is on the downlink and the Ethernet port number 5 is connected to the uplink. The PON port number 4 via fiber we are connecting to the ONU. So this is a bridge model ONT, and the port number 1 of the ONT we are connecting to a laptop. Coming from the upstream direction, so let's go in the upstream. The laptop is generating an untagged traffic without any VLAN. So this Ethernet traffic is being captured by the ONT Ethernet port, and the ONT is adding a VLAN number 200 and passing it on via the fiber to the PON port, and further on it is getting reconverted to the Ethernet format and going to the uplink on the VLAN 200. So before we log in, step number 1, the physical connectivity as shown here. And coming to the configurations of the logical connectivity, since this is a bridge ONT, we do not log into the ONT and we do not make any configuration inside the ONT. We only need to ensure that the Ethernet port of this ONT is in the bridge mode and not in the IP router mode. And then the VLAN 200 will be added by the ONT and then passed on to the OLT. Here we will do two sets of connections. So we'll add a GPON service profile here on the GPON side, and on the L2 Ethernet side we will create a ELAN service. Basically, in terms of the software configuration, we need to do only two steps: the L2 Ethernet service and the GPON profile attachment. So let's log into the OLT. So we log into the OLT with the username Tejas and password J72T05T. See here, this is the home page of the OLT. On the left side, we have the GPON folder. We navigate to the folder maintenance and then we open the folder manage ONT. Here we see that the target ONT which we want to make the connection is already activated. On the PON port number 4, it is detected as ONT number 1 and it's activated, and this is the serial number. And the most important thing is ensure that the ONT shows as MIB upload status success. It should not be showing as pending. So it should be seen as success. Then only the ONU will be able to carry the traffic. And the ONT state should be showing as online. It should not be showing as offline or ranging. Next, we can also see the optical power here. So we go here, filter the port number 4, apply, and we see here this is the ONT and this is the receive power. It is showing as minus 11 dBm, and this is the TX power and this is the receive power at OLT. So the power is shown in green color in the recommended range. Click this button refresh all just to ensure that the latest power is seen here. So fine. So the ONT seems to be physically activated and ready. Let's go into the configurations. Let's open the ONT, and as I said, we need to check whether the ONT Ethernet port is in the bridge mode. So this is the ONT page 1-4-4-1. So 4 indicates the slot number and the other 4 indicates the PON port number, and 1 is the sequence ID. We navigate below and click on the Ethernet ports. We see here this particular model of ONT has 4 Ethernet ports. So we are targeting the port number 1. We can see that currently the operational status is down because the physical cable is not connected to the ONT, or the traffic is not linked up. And the most important thing is we can see here it is showing bridge. So there are 2 modes, the IP router mode and the bridge mode. If we have to do any configuration inside a home gateway unit or ONU, we put it in the IP mode. However, since this is a bridge ONT, there are no configurations inside the ONT, so we need to keep this in the bridge mode. The physical port is in the bridge mode. Now let's straight away go into the configuration of the GPON profiles. On the left side, we can see there's a traffic configuration folder, and here we see the first option, upstream bandwidth profile. So basically we need 2 parameters. So I need to basically create 2 profiles and attach it to the ONT. So here we click on add upstream bandwidth profile and we give a easy name. So for the ease of identification, I am terminating the name with code UBP. That's nothing but the upstream bandwidth profile. So bridge service bandwidth 1G. So name can be anything actually, but we recommend giving easy, understandable, trackable names. So TCON type, there are different TCON types. We'll give here type 4. So in type 4, in the upstream, there is no fixed or assured values. There's only a maximum value. So I'm giving a maximum value of 1G. Now, the meaning of type 4 is that all the ONTs connected on the PON port will get a maximum bandwidth capability of 1G, and there is a DBA algorithm or a dynamic bandwidth allocation algorithm. So depending on the free buffers available and the user load, the ONT which has or which requires more load, the bandwidth would be diverted to those ONTs. I click on create. So we see here the upstream bandwidth profile is created. We need to encapsulate the upstream bandwidth profile into the TCON service profile. So I am giving it a code name TSP. Encapsulate the upstream bandwidth profile. So in case you have created a lot of profiles, you would see in the drop down menu. But since I have only one profile, we can see only one option here. Click on create. Next, we go to the TCON mapping profile. So the TCON mapping profile, we encapsulate the already created TCON service profile. So into the TCON mapping profile, we encapsulate the TCON service profile. Next, we have finished all the bandwidth profiles. We go to the VLAN tag operation. So I have a 1G bridge service and I want to apply a VLAN 200 operation on that. As I said, diagram or setup shown here. We can see here the laptop is generating an untagged traffic. So the ONT is receiving an untagged traffic. So the ingress into the ONT is untagged. So we select this option as untagged. We have so many options here, but we select untagged, the ingress. And the egress to have VLAN 200. Hence, we choose here the egress is single tag with a single VLAN 200. And the remaining values down below are all on default. We click on create. So we see that the VLAN tag operation has been successfully created. The ingress is untagged and the egress from the ONT is VLAN 200. Next, we have an option here, ONU upstream traffic profile. So here we encapsulate the created VLAN profile and we attach it to the port to which we want. So I'm giving a name, upstream traffic profile, and here I give a name, bridge service 1G VLAN 200. So these names ensure that you give names which are easily trackable and identifiable. This VLAN tag operation needs to be applied on which type of interface? Different types of interfaces here. So these are the physical Ethernet ports, or we can say the bridge interfaces. The VEIP is the WAN interface in an ONU. So this is applicable to home gateway units, but however, the current demo which we are showing to you is on a SFU or a bridge model ONU. And then the IP host 1 and 2, these are typically used for the voice service interfaces. So we want to do this on Ethernet port number 1. Let's say you want to do it on Ethernet port number 4, you would choose this. But I want to do on port number 1. So I do it on Ethernet port 1. I select the bridge service option here, the VLAN 200, the profile which I created earlier. And then click on create. My upstream traffic profile is created. Next, I go to this option, ONU profile configuration. We can see there are two ONUs detected. I want to do this as per the diagram on the ONT number 1. I go here, I select the ONU, and here I select the bandwidth profile, and here I select the VLAN profile. So this refers to the bandwidth profile and this refers to the VLAN profile. The remaining profiles here are discussed in another video. These are not essential for the traffic. Click on attach. So we get a message, successfully attached profiles to ONU. Go back to this folder, ONU profile configuration. We see here the bandwidth and the VLAN profiles are successfully attached. I have completed this part of the configuration. The GPON side of the configuration I have completed. Now I need to move to the L2 Ethernet side of configuration. Click on reload menu. We have this option L2 services. Before that, let me see if my port is up. I navigate to the card number 1 and the ports. We can see I need the Ethernet port number 5. The administrative status is up and the operational status is also up, which means the physical link or the cable is connected. So we can see here an authorization complete. So my port is up. What about my port settings? We have an option here called port configuration. What we see here is PON lag 201, 202, 203, 204. These are the PON ports, the L2 representation of the PON ports. And why it's mentioned as lag is because these PON ports can be operated in a type B PON protection scheme. So two PON ports can be clubbed for a protection mechanism. So here below, this is a physical uplink SNI port, port number 5. And we see here this option. This is called the switching parameters. So we click on the switching parameter. So here I am keeping the acceptable frame policy all. And if your input is an untagged traffic, you can add a VLAN here. But in a normal deployment scenario, it's recommended to keep the default number. Here we can see the port type. So the port type is mentioned as .1Q. So we'll select it as a combo port, so that in future we can pass a .1Q or a .1AD type of traffic as well. So just to repeat, this can be kept as a default value in a deployment scenario, but in a lab environment I want to have only one VLAN passing, so I kept as VLAN 200 port VLAN ID. I made the port settings. So we can see here the port number 5 is shown as combo port. Next I go to the ELAN services. Before that, let me create a VLAN template. So I go for a provision, new flow point template, then click on create. So let me create a new flow point template. So CVLAN is customer VLAN, typically used for .1Q services. And the VLAN number is entered 200. Create. I can have multiple VLAN templates here. So this VLAN template needs to be attached to the flow points or the ports. So I create a service. The remaining settings are all default. No need to alter the default settings here. So now I go back to VLAN services. I see that my service name is created. My service is yet to be created. So there's an option here, add new flow point. So click on the add new flow point. We can see here the flow point interface type is chosen here. Let me choose the combo interface. We can see the port number 5. This is the port which I need in my service. And I want it in the .1 queue mode, or the able to carry the .1 queue traffic. And I select the flow point template. The remaining settings are all default. Added the port number 5 into my service. Next, I need to add the PON port. Click on add new flow point and select the combo interface. Here, I can select one, or I can press the shift button and select all the ports. So for now, my traffic is on PON port number 4. So I want to select the PON lag 1-4-204. So this is actually the PON port, but an L2 or Ethernet representation of the GPON port. Then there's a .1 queue type of traffic, and then again here the VLAN number. The remaining settings are all default. Click on create, submit. So it gives you a warning or a guideline that wait for 30 seconds before you perform any other configurations on this particular port. Come back to the service. I see that my 2 ports are. Let us go back to the original diagram for the demo. You can see here I have completed the required configurations to pass the traffic. Now to test the traffic, I need to verify the packet flow, and of course the MAC address of the laptop should be able to be visible or read in the OLT, and in the same way the server connected on the uplink, this server's MAC address also needs to be read into the OLT. So this MAC should be read on the Ethernet port, and this MAC should be read on the PON port. That is, the laptop's MAC should be read on the PON port. Now let me check the physical condition of the traffic. We can see here on the screen, on the PON port number 4, the P4, this is a PON port. The LED is green color. That means the ONT is activated. And in the uplink, I have selected a physical RJ45 electrical Ethernet port. This is the, whatever I am highlighting here, this is the LCT or the login port. The port number 5 is a port which is on the top. So we can see that this port is up and ready. Now let's check for the traffic. So we navigate to the same VLAN service, and here we have an option called View Dynamic Unicast FDB Entries. So we see that we are able to read the uplink server. So there's an uplink server with a Tejas MAC. So that's coming from a Tejas switch. So from there, it's a DHCP server. I'm able to see the MAC coming from the uplink side. Now in the downlink, I have not yet connected the laptop. Now let us wait and verify for that. I have connected the client to the ONU. So now let's check if the MAC has been detected. So let's first check the physical status. I go to the ONT. So I click on the ONT. And on the ONT, we have this option to see the Ethernet ports. So on port number 1, I connected the laptop. See here the operation status is up. Earlier it was down. So now since the traffic link is through, it is showing us up. Next, let's see the traffic connectivity. We open the Ethernet service. We go to the VLAN services. View dynamic unicast FDB entries. You can see the MAC of the laptop has been detected. So this is a Dell laptop, and this is the uplink where we are connected a Tejas switch. It's a DHCP server, and the ONT side device is also seen here. So both the device, the handshake is complete. So this is one of the verification that the link is through, the traffic is through. Next, we can see the packet counters as well. Meanwhile, I'll show you a place where we can see all the MACs of the GPON side. So go to node inventory, click on the card number 4 GPON card. We see here an option, view OLT card FDB entries. So this lists all the ONTs in the network and their associated MAC which has been learned from the client side, and it also lists the VLAN number. So this particular window is a very useful window to extract or to monitor the various traffic working condition. Let us also see the performance counters, performance monitoring. Click on performance, then the current interval, then the Ethernet. Here we can see this is the Ethernet port number 5. We see here the data rate in bits per second and also the frames and the octets. So we have to see mainly two values, the received octets. This is the traffic downstream or incoming into the Ethernet port of the OLT. The traffic coming from the uplink side, and the transmitted octets. This is the traffic going out of the Ethernet port or the upstream traffic. So we right click and do a refresh. We can see the values are increasing. So let's see some flow of traffic. I've initiated ping response to the server. Number of octets have picked up. So as we refresh the screen, we can see the numbers are increasing. As we refresh the screen, we can see the numbers increase. So this is a way of verification that the traffic on the port is working fine. Then we can also verify the traffic on the GPON side. So on the port number 4 on the ONT number 1, so this is a GEM channel. So if we have 3 services on the ONU, there will be 3 GEM channels for the ONU. On this bridge ONU, there's only one service, so there's only one GEM channel. We click on submit, and we can see the GEM counters are also increasing. So this is a method to verify that the traffic is working fine on the uplink Ethernet side as well as the downlink GPON side. With this, we come to the end of the video presentation. To just summarize, we have described to you the steps to create a bridge service on a demo setup as shown here. So here the upstream ingress into the ONT is an untagged traffic, and the ONT egress has a tag on it passed on right up to the uplink. And we have shown that the service creation has very simple steps. The GPON side, a bandwidth profile and a VLAN profile, and attach it to the ONT. And after that, we create a L2 service on the traffic to the uplink. So this is the L2 service with the 2 flow points, the SNI port and the PON port. Thanks for watching this video. Until next time, see you again. Bye.